In this example, we're going to look at a process or algorithm, if you will, called Cramer's rule that we will use to solve a system of equations. So we're going to use Cramer's rule to solve this system of equations. So the first equation is minus x1 plus 4x2 plus 3x3 is 2. The next equation is 2x2 plus 2x3 equals 1. And the third equation is x1 minus 3x2 plus 5x3 is 0. So you can see that we have three equations, three unknowns, and we would like to solve for the unknowns x1, x2, and x3. One way to do that is to use row reduction techniques on an augmented matrix like we've done in many examples. However, here we're going to use this thing called Cramer's rule. So let's dive into that. The first thing we need to do for using Cramer's rule is put this into kind of a matrix format. So I'm going to form my coefficient matrix, -1, 4, 3, 0, 2, 2, and 1, -3, 5. These are just the coefficients of the unknowns from each equation. And then I need to compute the determinant of this matrix. That's one of the things that I need to know to be able to use Cramer's rule. So I have plenty of videos on the channel of how to do determinant computations. We won't go through the details here. If you compute the determinant of this matrix A, you should find that the determinant of A is equal to a -14. So determinant of A is equal to a -14. So that's one thing that we need to know. So now let's actually go ahead and solve for x1, x2, and x3. And the way that we do that is by doing more determinant computations to solve for x1, x2, and x3. So one at a time, we're going to do some computations and solve for these unknown variables one at a time. So let's start with x1. The unknown x1, using Cramer's rule, we can solve for it as the determinant of a matrix, and the matrix is matrix A with the first column replaced by the B vector. So you can see what I've done here. I've taken the B vector, kind of the right side of the equation, and I've written it down as the first column because I'm trying to solve for x1, the very first thing. The rest of this matrix is going to be the rest of the normal columns of A. So the column 2 is just column 2 of A, and column 3 is just column 2 of A. So the only thing I've done here is swapped out column 1 with B. And then I have to divide by the determinant of A here in just a minute. So I've created this matrix, I've replaced column 1. If I compute the determinant, I get the determinant is equal to 3. To actually solve for x1, I take that number and I divide by the determinant of A. So here I have 3 over a -14 because the determinant of A is -14. So this process right here of taking your coefficient matrix, replacing one of the columns with B, and then taking a ratio of determinants to solve for the unknown is what we call Cramer's rule. So I claim that x1 is equal to a -3 over 14. We can keep repeating this process to solve for the other unknowns. For x2, I'm going to write down my A matrix, but the second column I'm going to replace with the B vector. So column 1 and column 3 are column 1 of A and column 3 of A. The only thing I've done here is I've replaced the second column with the B vector because I'm trying to solve for x2, the second column, or the second unknown. So if I actually do this determinant computation, I get a -4. And now I can solve for x2 by taking the ratio of this determinant over the original determinant of A. So I get a -4 over a -14, which is 2/7. So x2 is equal to 2/7. And then finally, you can probably see what's going to happen here. To solve for x3, I form a matrix whose third column has been replaced with the B vector. The first two columns are just the columns of A. I compute this determinant, which is equal to -3, and then I can solve for x3 by taking the ratio of this determinant over the determinant of the original coefficient matrix. So it's a -3 over 14, which is 3/14. So I've solved for x1, x2, and x3. If we want to write down the solution more in kind of a vector format, we would say that the vector solution x is the 3-row by 1-column vector whose elements are x1, x2, and x3. And we have found that x1 is a -3/14, x2 is 2/7, and x3 is 3/14. So that is our final answer, and we got that final answer by using what's called Cramer's rule. Cramer's rule lets you solve for each unknown one at a time by doing just simple determinant computations and then taking a ratio of determinants. Obviously, if the determinant of the original coefficient matrix is 0, you can't use this technique because you'd be dividing by 0. But if the determinant is 0, then we know that we have problems with solving that system anyway because there isn't a solution.